Good morning, dear student. In the previous class, I have tried my best to finish the chapters because where there was a need to give the stress to solve the numerical, I have given the concept on it. But for the battery, the reaction is given. Suppose the question is asked, name the cell which is used in automobile. And actually, this question has been asked in the automobile, in the inverter. So this is a secondary cell, and secondary cell are those that can be recharged, right? Now the secondary cell give example lead storage cell and the cathode and anode reaction and the electrolyte. This is given in the books. That's why I not explain the reactions in writing on the board. Simply it is given in your book, so I only dictated. Simply dry cell, sorry, dry cell, that is the lead storage cell. Sorry, dry cell, Leclanche cell, that is used in transistor, torch, etc. And the another dry cell, the question is asked, name the dry cell which is used in hearing aids, electronic watches. So question is given on the basis of application and it need to be the you know or not, you are knowing or not. So by application you should know and write the electrode reaction. So we can write it. Similarly, name the cell that is used in the Apollo mission program, that is fuel cell. And what is the electrode reaction? It is given, that's why not explained on the board. Simply I have dictated. So, and what is are the application that I have also explained what are the applications. Now, one thing, there is a quantitative aspects I have written on the board, but the quantitative aspects means the based on numerical, such as aluminum 3 plus, how much charge is needed to deposit one. This is a quantitative aspect. So one heading is missing on that lecture. That is the I had explained the criteria of product formation of electrolysis. Actually, it was written that is the quantitative aspects of electrolysis. So it is wrongly written, but the heading will be criteria of product formation of electrolysis. That is the reaction that takes place at anode and at cathode. That will decided if in the chance of competition on the basis of reduction potential value and the oxidation potential value. I have narrated it and explained it very well. Alright. So this video will upload it. Now you will see and I hope you will understand it very clearly. I have explained it by giving an example. One thing is left in the value, that is over voltage and water in the case of chlorine and water. So I have written the value instead of 1.36, it is 2.36. So you will rectify it for Cl minus. This is equal to Cl2 and this is electron. So E oxidation, E0 oxidation is written as minus 1.36 volt. I was written there 2.36 because the value is 2.36 for magnesium. So these are the rectification of the previous lecture. Now, today I want to start a new chapter, that is unit 4. That is unit 4. First I write here unit 4. Unit 4. Today I able to manage the ink and that's why you will see some clarity in the board, because lack of ink I was not able to do I was not able to give the clear writing, not able to write in a clear manner. That's why. So this is unit 4. The chapter is chemical kinetics. So what are the learning objective in this chapter? Let us I will discuss later on. What is the kinetics? Kinetics means that is motion. This is the movement. This is kinetics. So what this chapter tells, thermodynamics thermodynamics tells about the feasibility of a reaction. Tells about feasibility. First we listen about feasibility, ability or possibility. At the condition delta G less than 0 or delta G is said to be the negative. And if for a reaction is feasible, there are so many conditions, and the last conclusive condition delta G, if comes to be negative, then the reaction is said to be the feasible one. So the thermodynamics tells about the possibility of the reaction, about the feasibility of the reaction, about the reaction that happens or not happens. That is, it is spontaneous, non-spontaneous, and it is the in equilibrium. But the chapter does not tell us about the kinetics, about the rate, about the speed of the reaction. So we study about the rate of the kinetics. This is the moment that is that tells about the chapter. This chapter tells about the kinetics or rate of a reaction. Rate of a reaction. This is the need to introduce the chapter chemical kinetics. Why we read? What is the purpose? First we know the need to introduce the chemical kinetics here. This is. So there are different types of the reaction. Suppose these are very fast reaction. Some are very slow reaction. And some reaction that takes place at the moderate rate. Moderate rate. So what is the example of the fast reaction? Simply, this is for our introduction only. This is fast reaction, that is burning a paper is a very fast reaction. When we add NaCl and AgNO3, then AgCl will precipitate out very easily. That is NaCl. This is a precipitation reaction, AgNO3, that it will give AgCl, and this is NaNO3. So this is a very fast reaction. So this is a very fast reaction. Now what is the slow reaction? We know the example, that is rusting of iron. We already know the mechanism of rusting of iron in the chapter electrochemistry. So what is the moderate reaction? There are some reaction that takes place not very fast or not very slow, that takes place in between these two, that are called the moderate reaction. And this moderate reaction, hydrolysis of ester, saponification means hydrolysis of ethyl sodium hydroxide. This is CS3 COOH C2H5 plus NaOH. So this is, so it will give CS3 COO Na plus C2H5OH. This is. So this is all about the introduction of the chapters. What is the rate? Now come on to the point. So what is the rate of a reaction? What is the rate of a reaction? So what is the learning objective in this chapter? What is the rate of the reaction? This is the rate of a reaction. Rate of a reaction, or rate that is change in is defined as change in concentration by time taken, simply time taken, right? This is known as the change in concentration by time taken, is known as the rate of a reaction. So change in concentration of the reactant and the change in concentration of the product. So there is a simple thing. If it is a concentration axis and it is a time axis, So the concentration of reactant decreases and the concentration of the product going to be increases. So suppose we consider a reactant, 1 mole of a reactant changes to the product. Let R1 and P1 are the concentration of the reactant and the product at time T1. At time T1. Now, it is changes to the reactant, that is R2, product P2 at time T2. So what is the change in concentration of the reactant? This is change in concentration of the reactant, that is R2 minus R1. This is red, right here, and this is T2 minus T1. T2 minus T1. And here it is written as, this is the product is equal to P2 minus P1 and the change in concentration by T2 minus T1. So what we see in the rate expression, that is we put the negative sign here and put the positive sign here. And this can be written as, that is change in concentration of reactant as given in your book, and this is delta T, change in time, and this is with negative sign, and this is also written as plus delta R by delta T. This is the, so when we put, this is called the average rate, here written as average rate. So rate now defined as disappearance, rate is defined as the disappearance of the reactant per unit time or appearance of the product per unit time. This is P, not R, this is P, delta T. So we put the negative sign, rate is not negative, right? So the negative sign stands for, because when the reaction proceed, the concentration of the reactant decreases and the concentration of the product will increases. That's why we put the negative sign in the rate of a reaction. So this is the average rate. So average rate is defined as the disappearance, or may be defined, that is change in concentration by time taken, change in concentration of reactant and change in concentration of the product by current. Suppose the reactant R1 at time T1 and it changes to R2 concentration, P1 at time T1 changes to P2 at time T2. So this is the average rate. So the rate now be defined as the disappearance of the reactant and the appearance of the product per unit time is known as the rate of a reaction. So term is very important. First we define the rate. So one term is defined here, and this is called the average rate of a reaction. So graphically the average rate can also be determined. This is the concentration. Suppose here R1. This is R1 and time T1, and it's a concentration when the time T2 and it is R2. So this is a time axis and this is a concentration axis. So what is the rate? This is called the average rate. Rate average, that is minus R2. This is at time R2 minus R1 divided by T2 minus T1, and this is represented by minus delta R by delta T. This is the average of the reaction. So average rate can be calculated. Average rate can be calculated graphically. Right? This is. Now the another rate, then we come into the equation. The another rate is the instantaneous rate. What is that is instantaneous rate. Instantaneous rate. What is instantaneous rate? The rate of a reaction at a particular instant of time is known as the instantaneous rate of a reaction. The rate of a reaction at a particular instant of time. So mathematically it can be represented. Mathematically, suppose R instantaneous, this is instantaneous, that is if can be written as R instantaneous can be written as if delta t tends to 0, that is for a small change in time and a small change in concentration. So if delta t, this is okay. So if delta t tends to 0, then R instantaneous is written as minus dr by dt. This is the small change in concentration and the corresponding the small change in, that is, time. So how we will determine the instantaneous rate graphically? So this is the problem. Let it should be very clear for you. Because some data are given, suppose here the concentration axis and here the time axis. Now here suppose concentration here is 0.01 start here, 0.02, and this is 0.03, this is 0.04, this is like that. So the curve is coming when we plot a graph between different concentration versus T, a graph of reactant for this type is obtained. Suppose we want to, and here the time interval 5 second, 10 second, and then 10, 5, 10, 15, 15, 20, 25, etc. Now we determine to the time, we want to determine the rate of a reaction at a particular instant of time, that is suppose 10 second. Suppose 10 second. We want to determine the rate at time 10 second. Time 10 second, not in between the two, that is the average 10 second. So what we will do, we take the point on the curve corresponding to time 10 second. Let it be point P. Now we draw the tangent this side. This is tangent. We draw the tangent and expand it both sides. Suppose here, if it is this one. So we take here, this is 30, and this is here, that is corresponds here. So this is the angle theta. So the instantaneous rate can be given from the slope of the curve. Slope, that is tan theta. Tan theta is equal to, that is if it is a reactant, then minus dr by dt. This is, that is equal to slope. By knowing the slope, we are able to calculate this one. So we take here corresponding to this, what is the change in concentration? Then change in concentration, if it starts from here 0, or put this is 0.1, like that, 0.4. So, and it is the change in time. So it will cut here and here. So what will happen? That is at 30 and at here 0, 0. The concentration is 0. So this is written as minus this one is corresponding time, we take it here. This is tan theta 30, that is 0, that is 0 minus, and here is concentration, that is 0.04. Now here time is what? 30, and minus at 30 second, if it is in second, the concentration is 0.00. This is called here, from here to here, if it is a reactant, then it is called dP, that is tan theta. If it is written as O, this is A and this is B, then tan theta is equal to, that is OA by OB. By that value we are able to find out if it is B. So this is 30 at 30 second, that is 0, and we take it at there, here is 0.0, that is 0, and 0 is that is 0, that is 0.0, that is 0.0. 30 second, and it is this curve cuts at here, and it will cut here. Here the time is starts from 0, that's why we put here 0. We solve it and we are able to find the slope, that is the instantaneous rate. So instantaneous rate means it is represented in this way, and average rate is represented in this way. This is our average. What is the difference between these two? That is big delta like triangle, and it is the small d and a small t. Small d means a small change in concentration, and the corresponding small change in time. So we can calculate it. If suppose it is not 0, then we suppose it is a curve like that. For product, if it is given, suppose curve like that for the product, how you will calculate it? This is, suppose the curve is like this. So you have to calculate here the at time t second. So you draw the tangent, and this value, this is the theta. So this is, if it is this is theta, so tan theta is equal to, that is p by b. So what will be value from here to here? This will be gives the vaccine, and this will from time here to here, and we, so instantaneous rate instantaneous is equal to, suppose here this is the time axis, this is the concentration axis. What will be the value of concentration? Here it is t second, and here it is, suppose it is 0, it is 5, it is 10, it is 50, and here the concentration is comes to be 0.01, and this is 0.02, this is 0.03, and this is 0.04. How we will calculate the instantaneous rate? That is final minus initial. So at time, what is here? 15. So minus, that is for the product. So that is 15, and the time here is 5, minus 5. What is the rate at 15 second? We write here, that is 0.03, and what is the rate here? That is 0.04, this one. So because we are calculating the instantaneous rate for the product, so its value with the negative sign is more, and this negative becomes a positive. Rate always be, that is for the product, will be positive. So this will the positive sign for the product, and we are able to calculate the rate of your reaction graphically. But the graph is not asked into the examination, but our concept should be very clear. So from the graph, we are able to calculate the average rate and the instantaneous rate. So it is defined, what is the instantaneous rate? That is asked in the question. The examination, the rate of a reaction at a particular instant of time is known as the instantaneous rate. And mathematically, if delta t tends to 0, then instantaneous rate is written as minus d, small d, concentration of reactant either or product by delta t. And graphically, how we are able to calculate for the reactant and for the product from the, that is the slope. And slope, how we will obtain the slope? By taking a point corresponding to that time and drawing the tangent, and from that tangent we are able to calculate the slope, and by knowing the value of the slope we are able to calculate we are able to calculate the value of the, that is the instantaneous rate of a reaction. So another points I want to discuss. Now the problem is best. So we are able, now we learn about the rate of a reaction and how we express the rate of a reactions. Suppose suppose we consider a reaction, very simple reaction. Suppose we take as twice, suppose in general we take A plus B in general, and this is C plus D. And it is asked to write the average rate. When average rate is asked in the examination, it is already written, you write the average rate. If it is rate is written only, then we only write the instantaneous rate. So there is no problem. So this is minus, this is delta A by delta T minus delta change in concentration of B by delta T, and this is plus delta C by delta T, and this is plus delta D by delta T. This is the average rate of a reaction. Now instantaneous rate, suppose if it is given AA plus BB, another example, write CC plus DT, and you have been asked to write the rate of a reaction. How you will write? R average, then we write 1 by A delta concentration of A by change in time minus 1 by B, this is delta change in concentration of B by delta T equals to plus delta 1 by C delta change in concentration of C by 1 by C, I have written 1 by C, then it is delta T, then is equal to plus 1 by D, and sometimes plus sign not written, but it is for the sake of clarity it is necessary to write it. This is the delta. So this question is asked on that concept, write the rate, and we have been asked to calculate the rate of appearance, rate of disappearance. If the rate is given, if rate is not given, change in concentration and time is given, we are able to calculate the so many things in that problems. So now we take the another example. Suppose this one. Suppose twice N2O5. This is dinitrogen pentoxide. Twice N2O5. It will give, that is 4NO2 and plus O2. So it is right. Now the question is asked, what is, write the rate of the reaction in terms of average rate. Average rate, what we write here? This is average rate. This is R average. R average AVE is equal to minus 2 delta. This is N2O5 by delta T. Again, reactant is only one, then plus 1 by 4 delta change in concentration of NO2 by delta T, and this is only one, so it is plus delta O2 by delta T. This is the questions for this one. Now if it is asked to write the rate, then we write only the instantaneous rate. If it is not specified in the question, write the rate of the reaction, we are free to write the rate in terms of the instantaneous rate of the reaction. So question similar, instantaneous rate or instantaneous. For the above reaction we can write it, that is For this one, we write simply, so it is also clear for that. It is better to write in another way. That is A plus B is equal to C plus D. And the question is asked to write the rate. So we write here the instantaneous rate. What is the rate? That is equal to minus dA by dt and minus dB by dt, and this is plus dC by dt, and what is here? Plus dd by dt. That is d by dt. So this is a small change in concentration, and respective to that of the small change in time. So for these reactions, if the coefficient is given, simply the instantaneous rate can also be written. This is average. Now this is the instantaneous rate. So simply we take the example, that is twice Hi is equal to H2 plus I2. Here is write average rate, and here write instantaneous rate, or simply the rate, or simply write rate. Rate means we are talking about the instantaneous rate. So what will happen? This is average rate, this is RAV minus 1 by 2 change in concentration HI by delta T, and here that is plus delta H2 by delta T, and here plus delta I2 by delta T, right? Similarly, if the equation is given and it is asked to write the average, that is average rate, we have instantaneous rate. For question this one, write rate. For question this one, write rate. What we write? Write rate. So we write here, this is rate means instantaneous rate. For the sake of simplicity and for your convenience, we write minus 1 by 2 delta N2O5. This is delta T, and there is plus 1 by 4. This is delta NO2 by delta T, and this is plus, this is dO2, change in concentration of O2 by delta T. So if we are able to write, then anything in the question if asked, we are able to calculate. Suppose the rate of decomposition of N2O5 is given. The rate of the change in composition, a change in concentration of N2O5. Suppose it is 1.34 initial concentration, and the reaction is going on. Its concentration changes to 0.345 T2, right? Then at a time is given. Suppose it is in 20 seconds. Suppose it is in 20 seconds, right? Find the rate of the reaction. So we are able to calculate it. So this is the rate of the reaction. For that formula, that is rate, we write here. For this is for this one. Change in concentration initial 1 by 2, and the change in concentration final minus initial. This is 0.345 minus 1.34 divided by time taken. When we put the value of concentration, there is no need to put the square bracket. So what is the time taken? This is 20 seconds. We solve it and find the rate of your reaction and write with its unit. So I will discuss what will be the unit. If it is mole per liter, unit, that is mole per liter, and this is time in second, mole per liter second. This is the unit of the reactions. This is the unit of this reaction after solving. Is that clear? So by noting the change in the concentration from this concentration, and it after time 20 seconds, the concentration of N2O5 comes to be 0.345 mole per liter, right? So at a time 20 second, find the rate of these reactions. Is it clear? Now, and it is said, asked in the question, what is the rate of formation of N2O5? What is the rate of formation of N2O5 at that time? So we correlate this equation. We correlate this equation and this equation. What will happen? That is, rate is equal to 1 by 4 into, that is plus sign, d and O2 by dt. So what is the question? That is, find the rate of formation of NO2. So rate of formation of NO2, that can be written as d NO2 by dt is equal to 4 into rate. So we are find out the rate for that reaction from the change in concentration, because these all are equal. If this is calculated, this and this can be equated, this and this can be equated, and this part can be equated. So if it is, I find out the rate, and it has been asked to find the rate of formation of NO2, from that rate we are able to find the rate by equating the equation. So the question, find the rate of formation of NO2. So we simply write this part, and we have to find out this one. So there is coefficient is 1 by 4. So we will multiply the 4 with the rate, and we are able to find out the rate of formation of NO2. So this is a very simple thing to solve the numerical based on the average rate and on the instantaneous rate. So how we will write the average rate and instantaneous rate, I have defined it very well. Now, one thing, so what is the rate and the unit of rate? So average rate I have discussed, and how will determine graphically, instantaneous discussed, and how will write the expression, it has already been discussed. Now what is the unit of the rate? Rate का यूनिट क्या होगा, इसके विषय में हमको जानना है. चूंकि रेट बराबर होता है कंसंट्रेशन बाई टाइम, सो दिस इज मोल पर लीटर एंड टाइम इनवर्स, वट एवर बी द टाइम सेकेंड वगैरह जो भी लीजिए वो आपको आ जाएगा. नाउ द another one is, that is the factors that affect the rate of reaction. Rate of a reaction. पहला होता है nature. Only you have to list this factor. Nature of reactant. दूसरा होता है concentration of reactant. तीसरा होता है टेम्परेचर. चौथा होता है प्रेजेंस ऑफ कैटलिस्ट. पांचवा होता है प्रेजेंस ऑफ कैटलिस्ट. देन पांचवा होता है एक्सपोजर टू रेडिएशन. And the sixth one is surface area of the reactant. Surface area of the reactant. What is the nature of the reactant? When the reactant react, it will form a product, and during a reaction, the bonds are in the reactant side, bonds are broken, and in the product side, bonds are formed. If the reactants bonds are very strong, then it will needs a very high energy to break the bond. So if the molecule is very complex, that is the reaction, that is the rate of reaction will be slow. If it is simple, that energy needed is less, the rate of reaction will be fast, right? Now concentration of the reactant. If we increase the concentration, then the rate of reaction will increase. How? This is a very simple example. Suppose we take the, that is a dilute HCl and this is conc HCl. We put both acids on the floor, that is marble floor. What will happen? When there is a concentrated HCl, the bubble will come out because the reaction will be very fast. So when we increase the that is concentration, the rate of reaction increases, and we decrease the concentration, the rate of reaction decreases. Now temperature. When we increase, suppose we want to we prepare the food. We want to prepare the food very quickly. What will happen? That is temperature will increases. That is we raise the flame of the stove in order to make the reaction very fast. So simply when temperature increases, the rate of reaction increases. If temperature decreases, then the rate of reaction decreases. Now what is the presence of catalyst? Catalyst, the substances which never consumed in the reaction, but it increases the rate of reaction without taking part in the, because without consuming in the reaction. So catalyst always increases the rate of the reaction by lowering its activation energy, that will be discussed in later on. So simply the presence of catalyst increases the rate of reaction. Suppose the reaction is very simple, KClO3, and if we heat it, then in the lab without the this one, that is 2 KCl and 3 wood. So it needs very high temperature, 650 degrees Celsius. It is very impossible to attain in the lab. So if we use the catalyst MnO2, then its temperature comes down 250 degrees Celsius and the same reaction will take place. So this is the role of the catalyst in the reactions. Now exposure to radiation, because the photochemical reaction takes place in the presence of the sunlight. So the exposure of radiation also increases the rate of the reaction. So surface area of the reactant. The surface area of the reactant can be clarified. Suppose we take the zinc dust and we suppose that take zinc piece and we take in a test tube and test tube and they added dilute HCl and here dilute HCl, in which case we see the reaction will be very fast. Suppose we take the common example, we take a log of wood and we take that is a flat sheet of wood and we try to burn it. So in what situation the burning of the wood will be very fast? When it is a flat sheet, then the burning will be very rapid. Sorry, because the area of contact of air with the fire will be more and the rate of reaction will be very fast. So when we take the zinc dust, the area of contact with dilute HCl will be more. In the case of piece, the surface area of piece will be less. The contact of dilute HCl with that piece of zinc is less. That's why the rate of reaction will be low. So today's topics I would like to stop up to that, and in the next class we discuss about the rate of law expression and the so many things. And I hope you will do the best numerical on that. This is very small topic. That is what is rate, average rate, write rate law expression, calculation based on a